Hi everyone, my name is Fredrik Backner. I am the Chief Analytics Officer with Kix and really happy to be back here at the Data Innovation Summit and presenting the last year's events with Kix. A year ago I was on stage and presenting some of the reflections when it comes to comparing telco, which was my previous industry, with the retail that I had just started. And today I'm planning to go through some of the learnings and some of the use cases that we have been focusing on with Kix in the last year. But before starting that, for those of you who are not too familiar with Kix, unless you're a woman, which is more familiar with Kix, Kix is the biggest beauty provider in the Nordics with 240 physical stores across Sweden, Norway, and Finland. And we have about over 3.5 billion SEK in turnover. And with 2.5 million members, we have a very high and loyal customer base, where actually 40% of all females or women, adult women in Sweden are actually a member of Kix. Kix is part of the bigger family of Axel Johnson, where you find other well-known brands such as Hemköp, Willy, Åhléns, Skin City, and many, many more well-known household names. We obviously, as mentioned, have a very big retail outlet with 240 stores, but also an exploding e-commerce also before Corona. After Corona, it has been just crazy in a positive way. Before we go into some of the use cases, I just wanted to give you a backdrop of the analytics architecture that we developed. When I joined last year, we had the top part in place, meaning the BI pipeline with SSIS, Kix Data Warehouse, or a Data Warehouse, and SSAS in place, and Power BI, of course. What we have done since then was to focus a lot on building up the machine learning and advanced analytics and more of the pipelining capabilities that is needed in order to be successful in analytics, where Databricks is one of the core components with its associated ecosystem with MLflow and DevOps, but also data lakes and real-time capabilities represented by Azure Event Hub and Azure Streaming Analytics. This ecosystem, I would say, is not radically different than most other cloud providers. It's just different names, but the design pattern are typically the same. I'm not intending to go through the architecture in much detail, but as part of Kix journey, it has been instrumental to build up this ecosystem to be able to capture the value of the data that goes far beyond the BI and the descriptive analytics, which in itself is extremely valuable, and much of the value still comes from that and will continue doing so. But in order to build up an architecture like this, you need highly competent skills. So one of the first focus areas for myself was to recruit solid data scientists and data engineers together with strong BI developers, which we now have in place since quite some time, and we are now capitalizing on building the use cases that I'm planning to go through. One more note on the architecture that we are in the process of doing. We are switching the more traditional Microsoft BI stack to Microsoft's new capability called Synapse, which is an entirely new ecosystem, making it possible to merge much of the analytics and BI into one and the same ecosystem, much more than what was possible before. That will address not only cost aspects and the performance from BI, but also help in bringing additional use cases to the table for also advanced analytics. So moving from the architecture and the technical dimensions as a backdrop, I'm going to spend a little bit on the actual use cases that we've developed on top of that data and technical architecture. One of the first use cases and products we developed was the Customer 360 or the Customer Data Platform that we use heavily in many other use cases, and not the least in our marketing automation, and when we manage the communication, what communication to which customer in our CRM platform. In the Customer 360, we capture anonymously all the transactions from our receipts online and in store, and we then build up a number, I think it's around 70 different parameters for each anonymous customer ID that we then run every night, which then are being used in subsequent use cases. Like, for example, the customer base KPIs, where we capture and track a number of KPIs such as churn, customer lifetime value, purchase frequency, amount of share of customers that are at risk, member shares, and which categories members are purchasing in, including also recency, frequency, and monetary value KPIs, and a number of KPIs in our customer dashboards. We also use the Customer 360 as a foundation, for example, for what we call the product reminder, which is a use case where we track the purchase a customer does on a particular item, and when it's time for that, based on the frequency of that customer, we identify when it's time to remind the customer to replenish that product with us. We also have, similar to the Customer 360, we have a Store 360 product where we divide our stores into different clusters, where we run a machine learning algorithm, k-means, to cluster the stores in different categories, and also make sure we can find twins across our store network. We also, of course, track the financial KPIs and which assortment that goes well in which store, and which assortments that we should discontinue or perhaps start selling in a particular store, just to name a few of the items. A final example that I'm going to mention on this slide, and by the way, on the subsequent slides, I'm going to go through a little bit more detail, the top use cases highlighted with a star. But one final use case on this slide that I think is worth mentioning is that we have built a campaign analytics product, where we, besides having the index, being able to track a campaign's performance compared to previous similar campaign, let's say last year, we also now have developed an application where we can see the true lift of an actual campaign, and thereby being able to see how much more did we sell from the categories included in the campaign compared to if we hadn't had any campaign. And to do that, we had to build an algorithm or make sure we get the insights of how much are we selling of a particular item in a normal sale, so to say, without any promotions or markdowns. So that gives us the valuable new insights in optimizing future campaigns and removing campaigns that are not profitable by itself. So let's go into a couple of specific use cases here in the subsequent slides. Most retailers with an e-commerce site have tagged them with using Google Tag Manager and are using Google Analytics to be able to track a certain number of KPIs, such as conversion rates and other aspects that are freely available in Google Analytics. What we felt that we were lacking was to be able to analyze the raw data ourselves, which you can do on an aggregated level in Google Analytics. So what we started up with relatively early was to capture that data through a freely available mechanism provided by Google Tag Manager, where you basically go into the Tag Manager and make sure that you send the data not only to Google Analytics, but to an endpoint of your choice, and in our case, Azure Event Hub. That then enabled us to develop a number of critical use cases, one being live sales, where we can actually track in Power BI together with our point of sales data that we also feed in real time to track the sales performance on an hourly level, actually even on a second level, which we started on, but we realized quite soon that that was not really what we needed. So that is one of the first use cases we started with, capitalizing on the raw event data made available by Google Tag Manager. We also started, we also then later developed a marketing attribution product, which in essence makes it possible to gauge the performance of each single traffic source that you invest in, meaning Google Ads or Google Display, Google Video, Facebook, and other social media, and being able to understand the importance of each individual, but also the combination of these sources in your marketing funnel to understand how much you should invest more in and what you should pull down investments in. This is done by can be done in two different ways, two different algorithms actually, shapely values or Markov chains. And we actually do a combination of those that we then benchmark with what is called last non-direct click, which is freely available also from Google Analytics. This helps us tremendously in the continuous rebalancing of investments in which channels and combination of channels that we should spend on our online traffic investments. That also gives us the ability to track the cost of sales and return of advertising spend by importing the actual cost data that you can get through APIs from both Facebook and Google, which then combined with this raw traffic data gives you ability to continuously track the cost of sales, which is important for any chief marketing officer. Similarly, we also created a dashboard where we combine our email systems with the raw traffic data, making it possible for us to track in one place the open rates and the click-through rates and the conversion rates of every single mail that we send out, to be able to learn through A/B testing which kind of messages and which kind of tone of voice and which kind of campaigns targets and gears is palatable to which customer segments. And we also use this data to create audience lists where we combine the CRM data with the raw traffic data to be able to create audience lists for Google similar audiences or Facebook audiences to be able to be even more effective in our targeting and which audiences we want to spend campaign money on. Customer lifetime value is something that most retailers are seeking to find out in order to understand the level of investments that should be done when acquiring new customers, and also benching that towards the cost of sales or customer acquisition costs. And what we've done at Kicks is we have approached this in two ways. One is calculating and understanding the aggregated customer lifetime value, which is the normal way of calculating customer lifetime value, by combining a bottom-up approach with a top-down approach. With the bottom-up approach, we basically we'll go 24 months back and look at the new customers we acquired that month. How much did they spend over the course of 24 months on average, and what is the portion of churn or customers that left us. Combining that method and with the top-down approach, which is where you firstly calculate the number of metrics on your customer base, like average number of transactions per month, average order value, the gross margin, and the average lifetime span, for the average time a customer stays with you. And then you divide this with the number of clients for the period. So a relatively simplistic but still effective approach of calculating the total customer lifetime value for your customer base. We, however, combine the top-down approach with a bottom-up approach to expand the horizon of a customer lifetime to understand the total lifetime value. That is an effective way of understanding the lifetime value for the customer base, and combining that with the customer acquisition cost, you get a good metric on how much or whether you overspend or underspend on acquisition cost when it comes to driving traffic to your site and purchasing traffic to your site. In combination with the customer base level CLV, we also calculate for each individual member the expected revenue for the next 12 months on each individual customer by training a machine learning algorithm using random forest to take a number of features like total revenue for the customer, the purchase frequency, the average order value, and a number of additional features. I think we identified a dozen significant features, which we then train a random forest model on, and which we then apply on a nightly basis to calculate every member's expected revenue for the next 12 months. We also then validate this with the actual spend to make sure that we have a good performance from an R-square perspective and performance metric perspective to see whether we need to retrain the model or not. So these in combination, the historic and the predictive approach, is something that is highly valuable for us and I would say any retailer to understand, on one hand, how much should you spend on acquiring new customers, and on the other hand, which customers do you need to spend more time with to either keep them stay if they're valuable or make them grow with you if they are a less spending customer, using marketing automation to have individual marketing messages to the customer. So another early bet for us was to build our own recommendation engine, since we at the time didn't have any personalization in our outbound emails, and we didn't have the capabilities or the means to do cross-selling or upselling in the numerous emails that we sent out. So we looked at third-party products, didn't really find anyone that fit the bill and our needs. So we set forth to build our own recommendation engine. And essentially, when you build your own recommendation engine, the core data source that you need is really the receipts and all the transactions, which you then use to build a matrix, or in our case, two matrices using collaborative filtering, one where you map items to items and one where you map brands to brands. And that is what we started with. And I must say that building the actual pipeline and the data prep and the data filtering is relatively easy. What really takes a lot of time when it comes to building a recommendation engine is to spend time on the business rules, where you need to when you need to make sure that even if the recommendation engine algorithm spits out 100 top ranked items relevant for a particular customer, you may not want to recommend them based on price points, whether it's too low margin, whether it's a too high price point, whether it's available clearly, and whether you want to push only news, or whether you want to push items that are marked down and part of a campaign. So we have spent a lot of time together with the CRM team in making sure that we have the tweaks and optimize the algorithm to remove items that shouldn't be there and push other items that we want to give extra credit for when in our recommendation algo. So now, since some time, we are running this recommendation engine in many of our outbound emails, matching the campaign that we push with recommended products in that campaign, and that's something that easily is self-financing. I can't give you any numbers, but the uplift we see when using a recommendation engine is easily in the 2-digit ballpark, and is really paying off itself. That, I think, is the last slide I have for our use cases. So it seems I have a couple of more minutes in my allotted time slot. And besides having guided you through the use cases that are vital for any retailer, and the tech stack that needs to be in place, in addition, of course, to the data, and what I haven't talked about today, the team and the importance of getting a strong team in place consisting of data scientists and then engineers and also data translators. And on the note of data translators, when it comes to getting the effects out of the data products and use cases that you built, it's so important to really upfront address the change management and liaising with your business peers, whether that's in your executive management team or other parts of the organization. So really making sure that you go from a push situation where you build it and hopefully they come, to get to liaising with the business to make them ask for and commit to actually using the use cases and the data products that you build. At that point, you come to the beauty of where the use cases are actually turning into hard money, whether it's on the top line or on the cost line. So with that, thanks for having me here, and maybe I'll see you next year. Thanks.